This is our linear growth problem. A bread company starts tracking how many loaves of bread they make every hour. They start fresh at 0 loaves every morning. At the end of hour 1, the bakery has made 15. At the end of the second hour, 30 loaves were made. Make a table to predict the following hours.
The X column represents the hours. You know that each hour the company makes 15 loaves of bread. So you can see in each hour there are 15 more bread loaves made.
The rule we wrote before is called the explicit rule, where y represents the amount of loaves and x represents the hours. And this is what the graph should look like. And this is what the graph should look like. Now we need to solve the following problem. How many loaves will be made in 16 hours? To solve this problem, we need to input our known values into our equation, our explicit equation. That equation is y equals 15x. Now we already know that the hours is x, so that would be 16, so that would make it y equals 15 times 16, and after you input that into your calculator, you get y equals 240 loaves.
How many weeks will it take to have 100?
Now on to our next problem. This problem reads, if 75 loaves are made in 5 hours, how long will it take to make 200 loaves? For this, we can use the y equals x explicit equation again. We would just have to input our known y value instead of our known x value. So that would make it 200 equals 15x. To solve this equation, we have to divide 200 by 15. And so 200 over 15 would equal x. Now 200 divided by 15 is 13.3 repeating. But you can't have a repeating decimal when it comes to hours. And 13.3 repeating is also 39 and 1/3, which is also equal to 39 hours and 20 minutes.
When will she have $90 left?
So the answer to this problem would be
Y
200 equals 15x, and x would be 39 hours and 20 minutes. About. The problem reads, when will there be at least 200 people with bread? Notice that this problem is not asking for how much bread is distributed, but how many people have the bread. As shown before, the equation is y equals 1 times 2x. 1 is the starting value, and it is multiplying by 2, which is the growth rate, raised to the x power. We're going to do what we did on the last problem and input the known value into the y. So 200 and for y equals 1 times 2 to the x.
We put it into x because it is the output.
So now we are on to linear decay. The problem reads, Cameron has a bag of 50 M&Ms. He eats 4 every minute, starting at 0 minutes and a full bag of 50 M&Ms. Make a table to show the next 5 minutes. This is what the table should look like.
This is the graph. You can see it starts at 50 and each minute it goes down. It's a decreasing graph.
Our equation is y equals negative 4x plus 50, and our now next is next equals now minus 4. Our start is 50.
Why did you put 2 slices? Thanks for watching.
This is our problem. How many M&Ms will he have left in 12 minutes? For this, we must input it into the equation. Our equation, once again, is y equals negative 4x plus 50. The minutes is the x column because it is the independent and is not changed due to the y. So it'd be y equals negative 4 times 12 plus 50. Y equals negative 48 plus 50, and that is 2 M&Ms. So after 12 minutes, he will have 2 M&Ms left in his bag.
So
This question reads, how many minutes will he have passed when he will have eaten 14 M&Ms? The equation is 4 equals negative 4x plus 50, like we stated before. And this is how it should be substituted in. 14 should be put in for y, and everything else stays the same because we know our y but not our x. And now you want to take the you want to take 50 and subtract it by 14 to put on the opposite side, and then you get negative 36, and that is equal to negative 4x because we just dropped that down. And now we have to divide it. So negative 4x under 4, and you leave the x there, and that is 9 minutes. So x equals 9 minutes, which means in 9 minutes he will have eaten 14 M&Ms.
Charles has $200,000. He wants to donate 10% of his money to a charity every month. Each month he takes 10% of what he has previously.
This is what the table should look like. And this is what the graph should look like. On the x-axis we have the month, and on the y we have the money in thousands.
In the table, you can see that each month it gets smaller by 10%.
The equation for this would be y equals 200,000 as our start value times 0.9 raised to the x power. 0.9 is our decay rate ratio because we take what we are originally donating, which would be 0.1, and subtracting that from 100% or just 1. So that would leave us with 0.9. X represents each cycle, or in this case it's every month, and Y is what is how much money he has left. Also for this we need to write a recursive rule or a next now equation, and next equals now times 0.9. Our start is equal to 200,000. This problem reads, how long will it be until he doesn't have any more money to donate? The first thing we're going to do is put in our equation y equals 200,000 times 0.9 raised to the x power. Now we're going to put in what we already know. So we need to figure out when y will equal 0 or $0. So we can already put that in. Our starting value. We're trying to figure out x in this equation. So the first thing we're going to do is we're going to subtract 200,000 from 0, and that gives us negative 200,000 is equal to 0.9x. The first thing we're going to do is divide by 0.9. So negative 200,000 divided by 0.9 is equal to, and that is what it equals to, and it is a long number, and it's not a decimal. There is a part that is a decimal, but that is, so that equals negative 222,222.2 repeating. After doing that, we want to find the square root because of the previously found number because we have x left. So that'd be the square root it's moving. Okay. 222,222.2, and the square root of that is about 471.4. So it will take this amount of months for him to run out of money to donate to the cause.